Starting the streaming. Oh yeah, and then as soon as that's, I'll kick the link over into the chat. Starting the streaming. Can I get somebody else just to say another thing? And then as soon as that's,
Hello.
I'll kick the link
Testing.
over
1,
into
2,
the
3.
chat. Okay, hang on. Starting the streaming. I'll see if that shows up now on the YouTube
Can I get
channel.
somebody
else just to say another
Do you want me to keep talking?
Then, as soon as that's,
Hello.
I'll kick the I think we got it.
Testing. 1, 2, 3.
Okay, hang on. I'll see if that shows up now on the YouTube
can I get
channel.
somebody
else just to say another
Do you want me to keep talking?
as soon as that's,
Hello.
I'll kick. Okay, all right. We audio is coming. Your audio is coming both to the Discord stream and to the YouTube stream. So we are free to engage as desired, and that's wonderful. So if you want to do audio, and thanks to Seth for who's not here yet, but no, thanks to Seth for kind of staying afterwards last time, and we pulled it together, and so that was helpful. So we should be golden rays of sunshine at this point. What we're going to do today is we are going to just dive into something. How about object diagrams? Did we finish sequence diagrams? Do you remember? If we didn't, we were dang close. Anybody remember? Okay, I'm going to pull it up. Thanks, Kevin. Kevin admits he doesn't know. We were talking about sequence diagrams. I'm going to just pull it up. We'll go to the back end and we'll figure it out. Let me see. I remember. Okay, I'll tell you what I do remember about sequence diagrams was we got to here. I know we got to here. I remember that explicitly, and I was saying that this guy actually builds in like the notion of an alternative, like a condition, like values greater than 10,000, or a loop where you iterate this thing a bunch of times. And I was saying that I didn't. Stream is not up on Discord. Oh, thank you. Duh. I forgot that. Yeah. Thank you. Man, every time I think I got it all just nailed, like I'm just a pro, then I'm just a dummy again. Every dang time. James, yes, everything will be finished grading this week. Okay, Canute asked how everybody did. I don't have an average. I will. How about if I have all that information on Thoy's, what's today? Monday? On Wednesday. What happens Wednesday? Oh yeah. Okay. Wednesday. I'm making a note. And I will talk about the midterm. Sound good? And I appreciate the heads up. I'm still kind of running a little bit frazzled, and really appreciate the heads up for where you guys are at, what you need, in the off chance that it just doesn't occur to me for some reason. Okay, so all right, alrighty. So sequence diagrams. Again, the idea though. Let me back up real quick. Notice that the questions on the side are there every time. What's it make you think about your design? What questions can you now ask? Again, again. Okay. And so this was one I said I didn't quite like, but I did get the idea of the alt bucket where you could put the two sides of an if then else, what you do in the one case, what you do in the other case. To me, it starts to get a little bit clunky and problematic. And then this one, which I think was, yeah, the last slide, which is the kind of thing I would put on a final exam. What thoughts about design do sequence diagrams induce you to have? That is the punchline, okay? The idea is, and it goes back to the orders of ignorance, that this generates a framework. The framework puts you in a position of being able to generate questions. You can now ask questions you couldn't have asked without the framework. Um, the bottom half of this slide, without an understanding of the concepts, in other words, the lack of the framework, you can't generate the right questions. So you remain at third order ignorance, which is where you don't even really know where to start. But where you always start is in being capable of asking the questions. Okay? That is always, and that is full circle back to the orders of ignorance. Okay? And that, my friends, is the end of that sequence diagram. So we are good with that. Um, oh, I guess I'm so tired. Let me do one more thing. Okay. Alrighty. Yeah, object diagrams. Okay, believe it or not, object diagrams has only one slide. Boink. No, no. So clever. No, there we go. There's a boink. That's it. Look, empty. That's it. The only slide. Uh, Here's the deal. Hang on. Let me drink something powerful, pure water. Um, the idea here is that, remember, class diagrams are all about the declaration, right? This is what a class looks like. This is what stuff, etc. Object diagrams try to draw you a picture of what the data structures. Essentially, it's the data itself, the objects as they're instantiated. Here comes an object. For example, this over here on the left shows you. I'm trying to figure out if this. Yeah, this gives you the corresponding class diagram. There's children and there's parent. That's child organization, parent organization, and there are persons and there are organizations. Okay, so a party. Now this is not like a political party. This is more like a party to a contract can be a person, or the party to a contract could be an organization. I'm making it up, right? Really bad. We got bad lag. Kevin, are we bad lagging on YouTube or on Discord? Struggling. Why are we always struggling? Why? Okay, hang on. Let me do a thing. Let me do a couple things. We always are struggling. Okay, hang on. Appreciate the heads up, by the way. The challenge is at this stage I can't quit much because I'm dependent upon a number of things that need to keep running. Let's go with that. Okay, let's see if that helps. And interestingly, I am getting the message on the YouTube stream that says YouTube's not receiving enough video to maintain smooth streaming. Hopefully it'll repair. Okay, let's see. Where are we at? Good now? Better? All right, let's take just a second. Really, truly, thank you for giving me the heads up in real time so we can get it fixed. Okay, so Kevin said it's better. Are we back? Is it functional? Or are we ready to go on? What say you? Better. James says better. Kevin says better. Better. Everyone says better. Okay. All right. So let me back up. Thank you again for the heads up. Really, really value it and appreciate it. Um, Up here on the left is a class diagram. It says parties can be either a person or an organization. The party always has a location. There can be 0 or 1 parent, and there can be a limitless number of children. Okay? That's what this is trying to say. Now, what then happens is this is an object diagram that relates to the same idea. So here is a thing called engineering, which is of type organization. It has a location, which is Boston. It is a parent. This is 2 child organizations or 2 child objects. One is called apps, which is an organization located in Saba. I don't know this place. I presume it's a place because it says location. And then tools is an organization located in Chicago. The point being that when this thing was running, this object was instantiated, and the object was given, whatever, it was set up with a constructor and stuff. And then somewhere when we used a setter of some kind to say your name is engineering, your location is Boston. Then that one, somewhere in the code, somebody said, hey, there's this new organization called tools, and we're going to, you need to spawn that one. So it tells it, make a new one of you and connect it in. So you make that connection. Then you connect the other one in. Then you talk to this object down here, Chicago Tools, and you do a similar thing where you tell it, you're now the parent of a new child. This one's a person named Don. Location is Champaign. That would be Illinois, more than likely. And then similarly with John, who's a person, location in Champaign. Okay. Yeah. Do you get the difference between this one is the description, this is like the dictionary definition, this is like spoken words. This is a class diagram, this is an object diagram. Okay? This is what you would see if you could follow like a dynamic real-time, what do they call them? It's like a profiler, but there are real-time, it's dynamic analysis, right? Static analysis is where you look at the code and it helps you understand how the things run. But dynamic analysis is to watch a running system. So if you paused for a second and said to the engineering organization, let's say there was a method built into the object class, and the method said, print yourself, then it would dump out this thing, and it would also say, dump out yourself and all of your children. So dump out yourself and go to the first child, and you'd see the tools in Chicago. It would dump itself out and then go to its 2 children, And whether you did this breadth first or depth first traversal doesn't really matter. Point just being that if you had a thing where this party structure could dump itself in real time, this is what you would see. Okay? So that's not the definition, that's the actual instantiation. This is really important. Is there any confusion? So along with a use case diagram, there could be a corresponding object diagram. that shows you when the use case runs and goes to here, here's what the object will now look like. Does that make sense? It could be, that's the best one I can think of. It could be a sequence diagram that says do this, and it shows you the whole sequence. And then at the end of which, it shows you. Let me see. Mike, do you have a hot mic? Hot mic. Wah, 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 wah. Mike, you have a hot mic. I just needed to say it. It's still hot, but there's no sound coming out of it. I mean, well, it's still not muted anyway. Hot mic. Okay. Any burning questions? Do you understand that about the difference between class diagrams and object diagrams? This also proves that Mike's like watching episodes of The Office rather than, oh, you just quit entirely. Is that what happened? Did Mike just bail? He's like, screw you guys. No, you're back. Hey, Mike, you're still hot micing on us. Mike's normally sentient in class, so I don't know what happened there. Should I mute him? No, I don't want to mute him because sometimes Mike actually pipes up with good things when he's not just hot micing. Okay. I'm gonna go survey. Sorry, Mike. We may make Mike mute Mike. Gunner, nice. Yeah, Gunner wins the chat so far with that really stupid comment, but it's almost like a dad joke, Gunner. I hate to say that as a dad and a grandpa, but I think yeah, Gunner is putting a okay. Yeah, Mike's repaired now. So okay, yeah, I'm gonna go with on uh, no on muting hot mic. All right, okay, back to wherever the heck we were. Yeah, I wanted to talk about next up. Next up is actually something really, really important. Okay, and there's not that many slides, but it's really, really important in state diagrams. And in fact, we allocate a couple days for state diagrams. It's a little easier to burn time in the classroom. And just understand that I'm okay sort of, getting through the stuff I want to get through. And if there's daylight left, Um, yeah, thanks, Mike. I mean, for the explanation. It was just like this. No, it's okay, Mike. It's good now. Keep yourself muted. We're not hearing you. Okay. What else did I want to just check on? Oh, yeah, that's object diagrams, state diagrams. Then we've got activity diagrams, communication coming up. I think we may get through the bulk of this today. Yeah. Up next is activity diagrams, communication diagrams, and then what I'm calling patterns of leadership patterns, another form of patterns that are not UML, okay, but they're actually related to leadership. And that's kind of like the core material that I really want to get through, you know. So let me see. Okay, I'm going to do another survey now that Mike is muted. The survey asks, I had CS 2810 from Dr. K. Yay or nay? Just out of curiosity. It's a race. the yeses versus the nos. Okay, and the only reason that I ask is for those of you, okay, this is for those of you, 2810 is computer organization and assembly language. Okay, 2 new surveys. All right, there's 2 new surveys. What I'm asking is the first survey, it's about 50-50, which is interesting in terms of those who had CS 2810 from me. Then the next survey question says, for those who answered, yeah, as in a finite state machine. Yes, Canute. The first survey question says, for those who answered yes, I still remember what a state machine and or state machine diagram is. That didn't even, I did not complete this. It's embarrassing. All right, I just tweaked those. Okay, so that's good. That's good. It says that that's cool. Some people, so Jet and Alex said discrete two uses them, right? So you get reinforced. So everybody remembers what a state machine is, what a state diagram is, and the utility of it, right? Um, so what I want to do, there we go, Kevin. Oh, nice with the whole like grammar thing, right? Yes. Okay, I just want to say I gave the speech previously in 2810, but there's a lot of there are a lot of systems. I can't speak, but there exist quite a few systems, and those systems um, kind of rely on state machines because the state machine describes what the behavior of the system is. And I love state machines. I mean, and I remember going through the, finite state automata and grammars and languages and, all that crap. And you're just kind of like, my life was incomplete without the pumping lemma. And you're like, Lord, help me, to get through this Garbaggio. And then one day I'm building a keyboard driver at HP for the original HP personal computer in OS2. And all of a sudden, it just like dawned on me that the perfect way to model a keyboard driver was to model it as a state machine. And I was building it from scratch. Nobody was advising me about how best to do it, which is, as I think about it, a very strange thing to let a new engineer do. But they did. And anyway, I realized that I could just do this thing in assembly language, where essentially you create like a process scheduler, and inside each state, if you did something and now that it's now the job of somebody else to do the next thing, you just change the state internally and ship it back to the processor who kicks it out to the correct next state. And you could model the entire thing. And once I had that, I had the architecture for the entire keyboard driver. It was still a pain in the butt, and you had to be pretty meticulous about it. But so Kevin said taking discrete math too totally changed how I think about programming. That's really cool, actually. But I just remember wondering, like, maybe there were professors who tried to explain that to me. You know, maybe that happened, or maybe they didn't, but I didn't get it, until I was out and I needed it. So it's possible that someone tried, you know what I mean, you know what I'm saying, to teach me. And it's also possible that they didn't, And part of what I'm trying to help you to understand is this stuff really, really matters because there is so much software. So what I wanted to do to kind of, oh, and then William said that Professor Allison, the other Chuck, um, taught it really well in an online. Was that in the discrete too? Again, William? That's cool. That's really, really cool. And of course, as we know, both Chucks are retiring. And, the other Chuck is probably the greater loss to the department in the grand scheme, although he's also older than me. And dang it, everybody deserves a break at some point. It's time for him to move on and get some rest. And, so I dig it. But anyway, other Chuck, Chuck the Elder, very, very good teacher. Really, maybe the best in the history of our department. That's my opinion, anyway. And I think I think the Chucks have represented fairly well. So anyway, Kevin said my roommate's company. I think so. You mean Kevin? I'm not trying to be like overly pedantic, but I think you're trying to say that the company that your roommate works for, or do you mean like a company that your roommate owns? Like, is it your roommate's company, or is it the company your roommate works for? Just yeah, he has shares. Okay, fine. They modeled their entire Internet of Things IoT update service as a state machine, and they've had maybe like one bug over the past 3 years. Yeah, because otherwise you're trying to keep track and remember everything, and the complexity gets crazy. So you can spin up a thread to just handle a certain thing, and it just makes its way and uses the state machine, takes the thread and grabs the next service moment, comes back in a different state, grabs the next service moment. The object can just grab the service request and say, oh, here's the information. Oh, that's in this state. I'll give that to this state to handle. And you then can conceptualize all of it in the form of a state machine. It can just be incredibly simple. So, I mean, not, I don't mean simple, simple in the state of like trivial, but I just mean it just matches and everything else becomes just cumbersome as hell, you know? So, what I want to know is, and it'd be great if you'd be willing to talk about it. What do you see around you in the wild that and I really would help on this one if anybody's willing to pipe up and be vocal, verbal on this one. But where do you see state machines in software, in systems, in the wild? What do just what shows up? And then we can kind of, confirm and deny, confirm or deny. And what I guess I'm really saying is you suspect by looking at it that it's running as a state machine. Mike says embedded devices a lot. You got to be more specific, Mike, or we're going to mute your butt one more time. No, we're not going to mute. We never did mute you because we love you too much. But no, Mike, embedded. You gotta explain what you mean by that, because embedded devices, all that means is it's sort of small and very, the software is very close to the hardware. No, what else? Keep working on that, Mike. What else? Just a specific device use model. Smart speakers. You got to give me why on that one, Derek. Smart speakers, maybe. Don't know. Every time we use regex, a state machine is used. Explain, Ali. Come on. Come on, pals. Oh, okay. So Derek's talking about smart speakers. You're in listening mode, idle mode, speaking mode. Maybe. Okay, no, I'll buy it. I'll buy it. How about like let's go, Derek, let's go Bluetooth speakers. Does that seem like a good idea? I mean, you're connected to the Bluetooth, you're not, when you're in the connected state of the Bluetooth, right? You're in a disconnected state, you're connected to other things. I have what the heck is it? It's a Bose, I don't know what it's called, but it's like this sound bar. I think they maybe call it the sound bar. It's up on my mantle. It's like one of these long Bose things. Creates a lot of sound, and I can connect to it with Bluetooth. I can connect to it directly from the television set, right? So yeah, I'm buying what you're saying, Derek. Um, Still waiting on Mike to explain and Ali to explain Canute. When you do regex, it creates a state machine that it then chunks through, makes it really efficient. I don't know about everything else, but Python definitely. Okay, that's cool. That's cool. Kevin, Flutter, a mobile app framework. I have heard of Flutter, and I do not have any hands-on experience. Although a bit abstracted, uses a state machine. Every UI part called a widget has an init, build, and dispose. Okay. By the way, the notion of calling UI parts widgets goes way, way, way back. The first time I experienced that was with what was it called? It was X Windows, which was a Unix predated Linux, a Unix sort of graphic interface for Unix. Oh, React calls them components. Okay, cool. What else? Let's get into more. You're in your car wandering the valley. Alex said technically any Turing machine is a state machine. So all computers are implementing a state machine in hardware. Yeah, man, what's fetch, decode, execute cycle? Now let's stop for a second, Alex. I did say get out in the world, but let's stop for a second, right? Go back to fetch, decode, execute. What are you doing, right? If you do, again, 2810, do you remember that there was an LC3 state machine? You fetch an instruction. What's the opcode? That's the next state. It goes to that state, handles the opcode, right? Decodes it, executes it, and then what happens? The machine grabs the next instruction, fetches it, pulls it in, decodes it. That's the state. Yeah, 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 yeah. Okay, so that's fair. I want to go. Okay, Kevin screams at us, rudely screams traffic lights. Ali says game development uses state machines for character AI. Yeah, 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 yeah. There was the Goth example of the gumball machine, William. Okay. I don't even remember it. I haven't looked at it in that long. Lance, I'm going to come back to Kevin. Oh, Kevin modified. Kevin went lowercase. Thank you, Kevin, for being respectful. No, Lance said all computers are a state machine with 2 to the number of bits of memory states. Fair. Let's bring it out. Kevin is the only one who said something in the real world. Well, William did mention Gumball Machine. That's true. And we did some examples in 2810, like the little turnstile. Kevin said traffic lights. Traffic lights are a classic state machine and one of the very, very first uses ever for the 8088, spelled 8088, which was the original processor. Oh, those units. Yes, those big, what do you call those things, Kevin? Those big, I'm gonna, since I got the picture here, let me throw the picture up over the top here. Those bad boys, so that it's in the, you know what I mean, so everybody can see it. Okay, hang on a second. LED construction sign. Yeah, I don't know. Roadside construction signs. Yep, yep. Those guys are state machines. They're running state machines. William said elevator, jet, the gear switch of a car, drive, neutral, reverse. What you need some punctuation in there, jet. The gear switch. No, I see what you're saying. Um, Maybe just a colon after car, right? So the gear switch of a car. You're in drive, you're in neutral, you're in verse. No, that's clean, right? What state am I in? If you forgot park, but right, there's park, drive, neutral, reverse, low gears, right? We do the same thing in a manual clutch where we're in first gear, right? Clutch in, move the thing, clutch back out, right? We're moving into different states that do different things. Lance, the original Goth book, which I have around here somewhere, um, gave network connections as an example of state machines. I will tell you this. Uh, Data communications, like you go to the Bluetooth spec, you go to the infrared ERDA spec, Wi-Fi spec, you go to any of these specs, they're going to be loaded with state machines, right? I'm in the paging mode, I'm in inquiry mode, I'm in connected mode, I've joined a PicoNet. The way I behave is, every second, every microsecond is influenced by what state I'm in. Yeah, but no, traffic lights. Let's go back to traffic lights, right? I mean, it. I'm in the green state for this direction, right? Let's just say only looking at one direction, one set of cars. I'm in the green state, and then, uh, right, I move from there to the yellow state to tell everybody, hurry up, because it's going to turn red. Then I move to the red state. From the red state, I'm thinking only of just one light on the main, whatever, it stays red. There it is, man. That's manic, though. No, Kevin, no, I'm right with you, man. It's not working. That GIF has got to be calibrated. You know what my favorite one is? I don't know if you thought about this one. My favorite one is the gas pump. Think about it. Think about it. Why is that? You think that there's a bunch of stuff. You walk up to a gas pump. There's a number of things you can do. You can pull at any moment. There's a bunch of things you can do. A bunch of buttons. So a keypad with a bunch of buttons. The handle itself you can pull out, put it into your tank. Um, the buttons on the different, premium, unleaded, whatever the type of gasoline we call that, right? I can put a card in, right? I can tap. There's all these things that can happen. So how does it know what happens? It waits for an event. It waits for an event. And based upon the event, that moves it into the next proper state. Now, one of the things that it should be capable of doing is handling it when you go outside of the proper order. So sometimes what I'll do, I don't do it so much anymore, but early in my teaching career, I used to get a kick out of going up to a gas station, going up to a gas pump, and just start pushing the crap out of stuff. Take the stuff out, put it back, push the gas. You know, a really bad state machine will just like freak out and start giving you free gasoline or something. It'll get confused. But it should know, look, I'm in the waiting. When you approach a gas pump, it's in the ready state, right? So from the ready state, if I lift the handle out, it should register a state of the handle being out. And that should be fine for the rest of the transaction. But typically it's not. Typically you have to wait until it says, please lift handle, which is in the sort of requesting handle lift state. Now you can lift the handle. But if you do it beforehand, it'll freak out, right? And some of that's just design trying to simplify the thing. But in an ideal world, there'd be like this duplicate of the state machine, basically, where in the one case you've lifted the handle, the other case you haven't. But if you've already lifted the handle, or you could register that more as like a, hang on, Wes, I'll get to you. Where was I going? Or you could register that as an event, and there's a difference between sort of edge triggered and level triggered, which is kind of a electronics reference. But when you deal with sort of edge triggered, it says I have to be waiting for you to lift it. I have to say lift handle. I see the lift because I was waiting to see the lift. That's edge triggered. Okay. But if instead, as soon as I lift the thing, it's like boink, I'm in the on position. I stick it in my car. Then when it's time for me to see if the thing's open, rather than waiting for an event to move me in, there's another timing event which says, now that I got here, check to see if the thing is already off. If not, if it is, count that as having happened. If it's not, don't worry about it. Does that make sense? But that whole interaction of a gas pump should be operable and describable as a state machine, and the operation of it should be resilient to any tomfoolery or hooliganism. Now, it may be that once you get too many weird button pushes, they make an assumption that you're trying to hack into the thing, and then just say, please see cashier and disable the thing for all. That's possible. Yeah, Kevin, hooliganism is your word of the day. Okay, Wes, by the way, I'm sorry. I meant to say, yes, student. So Wes called me professor, just plain professor. So he's now student, not Wes. I no longer offer him the respect of an actual name. Yes, student. I haven't played that card much, but you need to know it still does bug me to the bitter end of my teaching career. Doctor, Gunner, not Gunner understands, and I think you missed a few adjectives there, Gunner, like esteemed Mr. Doctor, Professor, PhD, Sir, or something to this effect. Yes, Wes, I'm just giving you a hard time, man. Oh, they are. It's just that what I said at the beginning of the semester was if you use my name, if you use my name, um, I appreciate it because I have a name. Instead of if you call me professor or just doctor, professor, it's like it's like this detached. I'm not going to bother to learn your name. Detached sort of. Oh hey, it's like I see a guy. He's got white hair. I'll just go. Oh hey, professor. Take a guess. You know, as opposed to Professor Knudsen, for example. Oh, wait, wait, wait. No, Wes, seriously. You have a professor that forces you to call. Wait, just like play. Okay, back, back, back. Back, back, back. Wes, let's talk for a second. Just you and me here. Let's have a heart to heart. Are you saying that this professor doesn't want you to even call him like Professor Jones or Professor Smith or Professor Brown, Professor Gupta? He wants you to literally call him professor and only professor. Is that what you're saying, Wes? Then I'll get back to your question. Oh, yeah, yeah, yeah. No, so what I'm saying, Wes, is I'm cool if everybody calls me Chuck. You know what I mean? Or the real Canute, or hey, Knutson, like high school gym locker room. Hey, Knutson. Um, I just like to have some of my name in there and not just be plain old professor or plain old doctor. Does that make sense? And so for me, I think when I was younger, I'm going to bet this professor's younger because when I was younger, I liked, you worked hard for that PhD. You know what I mean? You earned it, or you got this professor title. And then as I've gotten older, it's like I don't really care as long as it feels connective to me. Does that make sense? Okay. Um, Wes said the question is, I followed the key in the version of the book I had and got it wrong, only to realize it's different in another book. So which one's actually correct? I don't know. I don't know. It's my first time realizing this with the new book. Was the other one the Skater Chick book, Wes? The famous Skater Chick book? Um, it's one of those situations. Okay, let me just pull it up. Do you have I'm going to make a note and then I'll check it. And then anybody who got that wrong would just fix it. That's not hard. Who does what? State strategy template. Wait, what's the other one say? Oh, the difference is in strategy. Let's make a vote. I have my own guess. I mean, obviously, state is the same. We're correct on state both ways. Okay, state, strategy. I don't know. Do you want to try to solve this right now? Yeah, Tempest one was, I mean, strategy, that was our very first one, wasn't it? Hang on. Strategy pattern, page 24. Let's just take a peek. Let's figure this thing out. By the way, anybody else missed that? Okay, here's the definition of, at least in the Skater Chick book, strategy pattern defines a family of algorithms, encapsulates each one and makes them interchangeable. Right? Yeah, so what you have indicated, Wes, the auto grading there would be correct, objectively correct. But now the question is, the two pictures you grabbed, algorithm varies independently. Yeah, I'm not 100% sure. The other thing we can do, which question and which sort of, homework question. This was in the, no, this was in the homework, right? Yeah, we don't do questions like this in the exam. Yeah, Wes, if you wouldn't mind give me a little more information. Well, the other thing I can do is I can just go through and just mark that question correct for everybody, since it's just dumb. Since if these two sources exist saying contradictory things, you know, and I haven't looked in those books for so long, so I don't know. But you let me know which homework, and I'll go through and make sure they're all just everybody gets them correct. Cool. That seems fair. Seems ultimately fair. Okay, how are we doing on time? Okay. Mm. So Anthony said I originally had the actual correct answers. When I got to the end of the chapter, I saw the book had a different answer to mine, so I switched my answer. Okay, Goth 10, question 5. Yeah, I will fix. In fact, I think I can do that right after class. Yeah, ish. I think I should be able to. Okay, yeah. Thanks for the heads up on that, Wes, and thanks for being a good sport while I give you a hard time about calling me professor. Um, Let me see. Yeah, Landon. Hey, you. Yeah, calling you student. Are you saying at least he? Yeah, Landon. You talking to me, Mr. Doctor Professor? You. Um, no, I think the well, let's just do this. Let's just do it this way, Wes. I will just, as far as the homework is concerned, the grading, I'll go through and, you know, just fix it, make it correct for everybody. And then as far as getting it right, I can maybe try to look that up and come back next time, talk about it. Same thing with Lance asked the question, difference between strategy and template. I'm making a note to myself. See, one of the things that I feel like I've done kind of a little bit weakly week. I don't mean weekly as in the sense of every 7 days. I mean in the sense of being weak. Part of it just because of time constraints when I launched into this is basically being in a situation where kind of letting the Skater Chick book take you through Goth. I've mentioned I know a ton about patterns, but a lot less specifically about Goth. And again, based on time, what I haven't done is integrated that into the lectures to burn time on that. But where you have specific questions that I can kind of go look up, refresh, come back to it, and help understand it, that's great. I also, by the way, as you know, in the schedule, posted the videos to the guy, can't remember his name, who does some really good YouTube videos about the Goth patterns as well. So hit that as well. Um, anyway, Wes, shoot me a link or see what you can do, and then I'll take a look because I would like to know kind of at the end of the day who's right, who's wrong. Um, hang on a second. Okay. Just a second. Okay, I'm back. Ba-boom. All right. Wes says first edition is correct using the compressed. What is the compressed edition? What does that mean? Student? Oh, here we go. No, yeah, Wes, what's the compressed edition? What it means? What it means? Um, okay. All right, let me keep going. Let me hit some state diagrams for the next 20, and then we'll wrap up for today. And then we may get through this, and that's fine. But I just wanted to reinforce how important state diagrams were to everybody in your lives. It's very important. Okay. Now, remember, you understand state machines. You understand state diagrams, finite state automata, automata theory, languages, grammars. Well, this is UML. So what we're trying to give you is the UML version. So by the way, hang on. Wes said that you were using some funky book, but it printed in '04. Did anybody else have the same problem? You know what I mean? In other words, do we need to make it right for everybody, or is Wes the only one that got shafted by bad documentation? I'm going to make a survey. This is going to be because what I guess what I'm getting at is Wes. I'll fix yours, but if yours is the only one that fell doomed to that, oh Wes, put your answer as a response to my survey. No, yeah, no, no. You add. There we go. That's it. That's my baby right there. You can delete those if you want, Wes, and just click on the Y up top. Okay. Um, yeah, just curious. I don't. Yeah, I'm really. I mean, the new one, the non-Skitter Chick one, came out like just last year or something. So okay. So here's the idea, and as with always, as with always, um, You understand that these guys with the little arrow dashes are terms defined by UML, the final state, transitions, states, and initial pseudo state. So the initial pseudo state is a way of saying from here we enter the first actual state. And there's different ways of doing that, but it does at least define where you start, and it's like a pre-wait state. States are these little squares with the roundy triangles, not roundy triangles, with the roundy corners. Transitions, so from the wait state, this one, I wish that we were using, we have a candle, we have a door, and we have a killer rabbit. So I don't know what that is. Shades of Monty Python and the Holy Grail. Not sure. But we're going to break this thing down, into some of the chunks. Okay, so we're gonna get into it a little bit. But what you can see is from the wait state, you can transition to locked. From locked, you can be done, or you can transition to open. Okay, so from this position here, you've got these transitions. We don't actually identify, we do hear the notion of a trigger. Okay, there's a trigger signature, candle removed, a guard, which is a condition that has to exist before you do it, which is the doors. So the candle removed while the door is closed. Then there's a reveal the lock, and now you're in the lock state, not the locked state. And this is why I don't like this example. It's too much ambiguity. Don't make it harder, you know. But this is like in the I can see the lock state. Now I can turn the key with the candle in, which opens the safe. And again, the open, that's a verb. Open is a verb. Opened is an adjective. Lock is a verb or a noun. You know what I mean? Wait is a verb. I don't like the inconsistency. It's just if you're going to do an example, at least give it some, you know, give it some good. I just don't like the examples. Sorry. And I love Martin Fowler, and I think he's great. Some of the examples I think just suck. So this says that if the door is closed and I remove the candle, it reveals the lock. That's what that says, and moves me to this. I would call this the lock revealed or lock available state. Okay. Now, um, then I don't know what's happening here. If the candle is put back in when the key gets turned, then the safe opens. And again, open, I would call it safe opened or open or something that wasn't ambiguous between verbs and nouns. And then I can close the safe to go back to the wait state. Or I can leave the candle out and turn the key, which releases the killer rabbit and kills me, I guess, is what the idea is. Um, yeah, Seth. So Seth asked maybe a mutex, kind of a semaphore lock would be a good example. That's what I assume this diagram is shooting for. Yeah, I think so. Kevin, I like idle, opened, and locked. Yeah, I like that better. Okay, let me keep going. All right, so one of the things I can do inside a state, is I can identify things I can do within that state. Like I can be in the typing state where I can enter, I can exit, I can, what I can do. I can hit help, opens the help page, etc. I can basically identify the things that I can do when I'm in that state. Now, you can also make this, and what that allows you to do is a certain amount of granularity. One approach is you can, um, make the state machine so granular, so tiny and granular that you never have to do this, because I would do the I pressed a key state, but that can be really cumbersome as opposed to I'm just typing normal characters kind of state. So no matter what character I type, I stay in the typing characters. So when I hit like escape, then it's different. So remember I said, you never do any diagram with everything you could possibly say. It's always an abstraction. That's the idea. You got to find a balance for how much information to say to allow me to code the thing, right? Like Vim's insert mode. Yes. Yes. VI. Oh man. I'm going to make something. I'm going to make a bold statement. In a world in which we have modern, VI had a role to play in an early world of sort of command line interfaces. In a world in which we have a graphic editor, I don't think it makes any sense whatsoever. You're like, I know, but I'm good at it. Yeah, well, you know, you're probably good at that slide rule too, or that abacus, but maybe a calculator is going to come in handy one day. I don't know. Do you see me doing do you see me doing the kids these days thing? Especially your generation, I really don't. I really don't understand. But there's one that's worse, which would be Emacs. How many of you are familiar with Emacs? Emacs was created by Richard Stallman, which probably should tell you most of what you need to know. There's an old joke that says the easiest way to create a random number generator is just to put a user in an Emacs session and tell them to quit. Boom. Okay. Activity states. What do we get to already? What do we do? Internal activities. Activity states. Update. Now also, once again, update is an imperative verb. Searching is a gerund verb with the ing. Display. So update hardware window, display hardware window, searching. Do search for new hardware. At least have the verb tenses agree. You know what I mean? It just introducing. It's all the design things we've talked about. This is why I'm telling you about elevators and crap. So when you get to here, you also realize that there's a similar idea. Everything you do that burdens my job of trying to understand what you're talking about makes the world harder for me. Okay? So for example, I don't know where I start here, but I'm in the activity states. So I'm in the update hardware window state. I perform a search. There's a trigger of some form that transitions me to searching, where in that state I search for new hardware, or I can cancel and go back, or I can display new hardware window. I don't know. It's a piece. It's not a full thing. Super states. By the way, I've got super states, concurrent states, the Goth state pattern, and that's it. Okay, for this one, which means depending upon what time it is, uh, 10 minutes. You can get close. Okay. By the way, can I just say, do you like the design of this was in fact playground equipment when I was a kid. The kids today are soft. You know, there's more truth to that than I'd like to confess. The things we did as kids was really something. I died once when I was 5, and my mom made me walk it off. Just rub a little dirt on it. I don't know. That was a different generation, that's for sure. The truth is that kids died, and so that's why they made changes, broke their arms and crap like that. Um, yeah, no. What happened, Craig, was I walked it off, and then that was that. I was back rolling. Um, Yeah, that's well, okay. Yeah, now we're under like 305G, but I just got to say, Wes, this is true of every generation, right? That there's challenges that every generation faces that have repercussions that don't play out until like the second or third generation. It's a perpetual ripple, and every generation is a product of what they were kind of blessed by and what they struggled with. Some of which is going to turn to their good, and some of which is going to turn to their crap. And every generation has it, and every generation does it. And I don't believe there's a monotonically non-decreasing function of always getting better. I think it cycles through good and bad. That's my own. I mean, I don't think it. There are those who think it's monotonically non-decreasing function getting better. Others who make the same statement, but it's getting worse. And I don't think it's true. I think it cycles. Right? My opinion. What do I know? I'm an old man about to retire from academia. Okay, superstates. What's the idea here? Oh, yeah. I can have a state like show connections, and then I can do new and go to. I'm ignoring the details and the nuance of the actual system, but I can get this new event and go to enter connection details, and then I can come back from it. So that's where I can view it as the superstate, or I can say, turns out that enter connection details is itself comprised of a state machine internally. The problem here is that this whole cancel and save doesn't really kind of feel right. You know what I mean? Unless the cancel arrow was closer over here. So it's like new, no, go back. I didn't actually do that. Otherwise, I do new and I come back as save. Where I've got a little pseudo state that when I come in here, I kick into enter phone number, choose shared or solo, enter name, and come on back. Make sense? Okay, and then we've got this notion of concurrent states. This graphic I don't like, but it's just trying to say that I can show different states at the very same time. Okay, that's all this is really trying to say, and I don't care too much about it. The history pseudo state I don't care about. You know, it's not a great graphic anyway. But this is trying to. I think this is trying to show like a CD radio alarm clock, so I can have like radio functions, CD functions, and that's like an either or. But then there's a concurrency boundary where it's also displaying the current time, displaying an alarm time, right? And you could say, well, really, well, all that's really happening is that it's different circuitry. It's really like two different devices that just are like in the same packaging, in the same case, in the same, molded plastic case. And what it really kind of says is I don't have to be thinking about the CD when I'm displaying the alarm time or dealing with the alarm clock. Similarly, when I'm fiddling around with the current time, I don't have to think about playing the CD or the radio. So it allows me to say they're both part of the device, but the device has like two different functions and I can treat them separately. And whereas this one says I can treat any state machine that's complex as a substate. Like I'm typing regular characters, and internally it's like press goes down, register scan code, send scan code, key press goes up, typomatic rate, and a bunch of other things. Like if you hold a key down, it goes brrr, right? You like my sound effect? I'm pretty pleased with it. Okay, and then this gets us to the Goth state pattern. And again, I mentioned before, like let's not get carried away with what Goff did for the world. It did some great things for the world, but it didn't invent the state machine. And if to the extent that it does say, well, but it's way better than a regular state machine, then it's kind of a little bit in conflict with Christopher Alexander, who said that the issue itself should be repeatable a million times while always embodying the essence, the essential gist of something. And in that way, the Goth patterns are not kind of traditional Alexander style patterns. But this is, and I don't, have you gotten to this one yet? Did you do this one already? I can't remember where it falls out in the Goth book or in the Skater Chick book. Anybody? Bueller. Did you guys get through this already? I can look. Don't make. Is everybody asleep? Did it do it? Kevin did. Seth didn't. Now we have confusion. Okay, fine. Seth is a failure. Yeah. You don't have to make the confession publicly, Seth. Um, anyway, it's just meant. Oh, there's the candle again, and this candle removed. I don't know, but it does at least give you the idea of what you can do, or what the Goth pattern is trying to do in terms of implementing this. Again, my big nit is just this is not the embodiment of the notion of state machines. It is the embodiment of a very specific object-oriented paradigm for a sort of a Java or C++ based piece of code to do a thing, and it may not even be the right thing to do, and it certainly isn't the way that I would think of it or do it if I was doing it in assembly language. So that's my biggest net with Goth is it's just too narrow, and overly narrow is what Alexander was talking against. That's my big net. There, I said it. I mean, there are some folks in the patterns community that already know how I feel about it, for whatever that's worth. Alrighty, hey, I think we're actually close. And the next slide is nothing. So I think we should call it. And then we're going to kick back in on Wednesday um, and jump into whatever I said we'd do next. Activity diagrams. Yeah. Activity diagrams. There's a few slides. Oh, no, activity diagrams is good. Activity, you're going to like, we need at least 2 days for activity diagrams. Okay. I already know this. And then communication diagrams, it's very, very small. So I think we should be able to get through activity diagrams and communication diagrams by like end of next week. We've only got like 3 weeks left. The next week would be patterns of leadership, and then I would just call it whenever we get to that point. We'd just be done. Go have some Nikos, see what happens. Okay, my friends, that's all I got. Hasta lasagna. I'm gonna do my shutdown.